Hey everybody, this is Larry. This is me along with Q3 of the bi-weekly Contest 40 Design Front Middle Back Q. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I think it's a really cute problem, and as usual, these problems require a bit of figuring out what the invariant is, and the invariant is something that doesn't change after you do one of these operations. And for me, the way that I thought about it during the contest was that, okay, we have to push something to the mid and we have to pop something from the mid. So the easy way for me, just to think about it, was just to have two queues, right? But given having two queues, there are a lot of things that we have to kind of, maybe not a lot, but a few things that we have to consider, which is what is the invariant that we're trying to hold with two queues, right? For me, and this is why I took so long on this problem, is thinking about that problem. So I have two queues or decks in Python, and my invariant is that the left queue is always going to be at most one less than the right queue, right? So either they're equal or the left is one less than right. So why did I want that? I want that so that, so let's just say we have something like 1, 2, 3 on the left, and then 4, 5, 6 on the right. So there are only two scenarios, right? One is when they're equal, and then when we want to get the mid, we get it from the left side, right here, right? And then the other case is, let's say we have odd numbers. Well, in here, then when we pop the mid, when they're not the same, we get it from the right side, right? So that's basically how I think about those cases. And then once I do that, I basically, after I do everything, I just make sure that this invariant holds, which is that the left and the right has the same size, or the left is once more than the right. And once you do that, once you figure out that invariant, all the operations will follow through. You just have to kind of make sure that's the case every step of the way. So for example, push front is easy. You just push it. And that's why I have a helper function that I call fix. Terrible naming for sure. But what fix does is that it goes over the two cases, right? One, which is if the left is bigger than the right, then we pop one from the left and then we put it to the right side. And if the right side is bigger than the left by more than one, then we take it from the right and push it to the left. This is kind of similar to the rolling median problem, if you're familiar with that, with two heaps, but that's basically the idea that I kind of dealt with. And yeah, looking at front, now that we have this fix function that does this fix, then we can do this along the way. And I actually sprinkled it everywhere because I wasn't sure if I keep on needing it. And it affects performance a little bit, and we'll go over the complexity of this in a sec, but that's basically why. So push front, you have two queues. You can think about what push front is. You just push it to the left queue, and that's it. And then you fix to make sure the invariant still holds afterwards. Push middle, as we said, it doesn't really matter which one you push because the fix function will fix it for you. So you just have to push in one of the middle ones. I just chose the left one for fun. It doesn't really matter. You could, as long as you push it to the back of the left one or the front of the right one, the fix function would fix it for you. Pushing the back is also similarly trivial because once you push it to the on the right side, it'll just fix it for you, right? Just push it at the very end, and then the pop ones are interesting now, right? So you have to check that, if there are no elements, that means if the left and the right are 0, then you -1. Some of these cases I just made sure that for myself, because I am not, when I implement this during the contest, I was, to be honest, very not confident. And I spent a lot of time testing this during the contest, which is what it took the bulk of the time. And you could watch me during the contest for that, to kind of see that how I test this as well, and to visualize it so I could at least have some confidence, because every wrong answer is 5 minutes, and I don't want to get into a thing where like I'm fixing one thing and then fixing like 5 things, right? And then it ends up being like a terrible contest. But yeah. So for popping front, if there are no elements, -1. If there's and we know that we don't have to check that the right doesn't have any elements, because as I said, the invariant is that either they're the same, which means that they both have 0 elements, or or the left has 0 elements and the right has 1 element, right? So we just check to see if the left has 0, and if that's the case, we take it from the right and we pop. We should actually also fix this, but I think this only but we don't even need to do the fix because this only happens if the right has only one item and the left has 0 item because of the invariant, and we know that invariant to be true, then this will just be 0 items. Otherwise, for me, I just popped it from the left and then have it fix itself afterwards. I don't even think I need this one to be honest, but I sprinkle them liberally because these are cheap, and we'll go over the complexity and how much these cost later. But yeah, pop middle. Pop middle is okay. Let's do the pop back first because it's also easier or more obvious. And you kind of see what I did here is that I actually tighten up the code that I don't even need to check here because on the pop back, the right is the element that has the extra element. So obviously if there are no elements, you return -1. Otherwise, you just pop 1 from the right, and then we fix it afterwards to basically rebalance the left and the right, right? And before, just in case. I don't think it's necessary to be honest, but I just kind of do it there. And then pop middle is the fun, tricky one, which is then, we go over all the cases, right? If there are no items, return -1. We talked about this. Should be straightforward. Otherwise, we make sure that this invariant holds. Again, because we do it at the end every time, I don't think this is necessary. But I like to be careful, especially on contests, because sometimes you rather that you don't have to prove things than wasting getting a wrong answer and getting 5 minutes, right? And then the other cases, okay, so the only 2 cases, as we said in this invariant, which is that they're equal. If they're equal, again, we already talked about this, we pop from the left, and if they're not equal, that means that the right has 1 more element, so you pop it from the right. And then we fix the invariant after that. I think technically you don't actually need to because this ensures that invariance to be true. But again, I just like it's almost free, so I keep doing it. Especially given that there's at most 1,000 cores, it's gonna be fast enough. Okay, let's talk complexity, right? So this one, it's a little bit weird. I wrote it as a while loop just because I was too lazy to prove it, though I knew that this was mostly true. But this could be actually written as an if statement because if the invariant is true and you only make 1 change, this can only be one thing out of place, right? So yeah. So this fix function, let's go over it. This is going to be O of 1 because at most you're popping 1 item, and that's going to be O of 1, and then pushing it to the other queue, right? So you have 2 queues, you're taking 1 element and then pushing the other queue. So, and obviously both these things cannot be true, but even if it was both can be true, you only do like 2 operations for each element. So this is going to be O of 1, right? So now knowing that this is O of 1, we can kind of look at it that way, right? Now push left, we know that this is O of 1 because we just push 1 item, so, and this is also O of 1, so this is O of 1. Same reason, this is O of 1 because all these are O of 1 operations. Same for push back, same for all these things, and you could kind of go for all these yourself as well, which is that all these are true, that these are O of 1 operations and these are O of 1 operations. So all in all together, every core is going to be O of 1. And you can't really do better than O of 1, so that's all and yeah, and space, of course, is going to be O of n, where n is the number of items, because again, you have to store the item, so you cannot be, so that is the lower bound, you cannot do better than that. So in terms of space, total is going to be O of n, per operation is going to be O of 1, you could say O of n for, or O of m for m operations. But yeah, that's all I have for this problem. Feel free to watch me attempt this problem live during the contest, and you could kind of see how I do the testing as well. Usually, to be honest, I don't do this much testing, but this one, it just feels like there could be a lot of weird off by 1, so I really wanted to make sure to be confident. But yeah, you could watch me solve it live during the contest now. Cheated. Not gonna lie. Okay. Push 1, push middle. What is middle? Okay. Just pop. Okay. When they're equal, that's fine. When they're equal, that's fine. This also needs some rebalancing. This is going to be annoying. Otherwise, that. That's not the case. It's okay. Just what I'm not confident about, to be honest. That's not good enough. Let's see. Come up with a test case. This is really hard to construct a test case. Yeah, I thought that would happen. Yep. This isn't even the right thing that I'm fixing anyway. Oh, right. Let's see. It's such a annoying thing to test for. Oh my god. Push one. Okay, that's good. That's good. Okay. This invariant is good. Oh, pop fun. Okay. Did I miss one? Yeah. 3. Okay. Okay. Whew. Hey everybody. Yeah, thanks for watching. Let me know what you think. Ask me questions because that's the only way I'm gonna know how to answer them in the future. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all next problem. Bye bye.